In any job of any size, there's going to be some task that sort of falls into the crack between a couple of subcontractors, where it's not either of their responsibility, or one of them is in a much better position to accomplish part of the task even though it's not part of his craft. And these gate posts are certainly that. Now, the fellow that's going to build the gate could have fabricated these gate posts, no problem. And he could have installed them, no problem, except he would have had to mobilize a backhoe, and he would have had to bring the concrete, and he would have had to brace them up and protect them from being damaged. And he has no reason to be on the site except for that. Not only that, but the footing on this gate post is going to be tangled up with the footing on the block wall, which is immediately adjacent to this post, which means that the man who already has a backhoe and a forklift and a concrete truck there, the block mason, really ought to be the guy that puts these in. But he's not going to be the guy to build them. So now, do we coordinate between the fabricator and the block mason and try to get their schedules to coincide so neither one of them hangs up the other man's production schedule? I don't think so. Nate and I decided we'll just build these gate posts. We'll get them to the site. We will have the fabrication already taken care of, and all the picking eyes and the bracing attachments and everything that's needed in order to put these things in the ground ready to go on them, and then make a deal with the mason to put them in place. So he can coordinate that with his footing dig, with his footing pour, with bracing them up and then laying the block up against it. Works great that way. So the only thing that the engineer specified relative to these posts is that it has to be 8-inch square tube, 1/4-inch wall, set 6 feet in the ground in a 30-inch diameter footing. That's easy enough. But there's a whole broad general category of buildability associated with an engineer's call-out. And that is, here's what we need, but is it possible to do it that way? So everything that we've done to these posts here in the backyard this afternoon is to make it buildable, convenient, to make it possible to get a nice job on the installation. We've put caps on both ends. The cap on the bottom is so a 500-pound piece of square tube doesn't sink 6 inches into the loose dirt at the bottom of the hole and render itself impossible to move side to side to get it in the right location. The cap on the bottom will keep it from doing that. The cap on the top is to keep it from filling up with dirt or water, although it is Arizona after all, but to make a place to put a picking eye, a place to suspend the post so it can be carefully lowered into the exact location with a forklift on the job at installation time. The anchor bolts have been welded to the side so that they can penetrate the block wall, be grouted into place, and put the block wall and the post functioning together as a single unit. The 1/4-inch plate tabs with the holes drilled in them that we've located on 2 sides are for attaching braces. So once this thing's in place, it can be held exactly plumb in exactly the right location. So all the work here that we did this afternoon on these things was strictly for convenience and buildability. These tubes are not a common item. 8x8 by 1/4-inch wall is a serious square tube. One of the advantages of being in a big city, Phoenix, is that we picked this stuff up the next day. We called one morning and picked it up the next afternoon. That is some pretty serious convenience. 500 pounds a piece, $500 a piece. That's a lot of money, isn't it? Yes, but it's a nice piece of material, available when we need it, perfectly to spec, nice and clean and oiled and smooth and brand new, and there's some value in that, isn't there? It's sure nice welding on new iron. There are really only about 3 things that are critical in the installation of these posts. The most important thing is that they're installed plumb. I mean really plumb, because the gate that hangs off this is only going to operate smoothly if the post is plumb. Whether or not it's an inch or 2 to the right or to the left or to the front or to the back, nobody cares too much about that, but boy does it need to be plumb. The next thing that's got to be right is you got to have at least 6 feet of embedment in the ground, and the footing's got to be at least 30 inches in diameter. That's important primarily because it's going to be inspected, and if you want to pass the inspection and not have to pull it out of the ground and dig again, it's got to be 6 feet in the ground, and the footing's got to be the right size. There is a third aspect that is somewhat critical, and that is that it is set with one of the faces parallel to the line of the wall. There's a little bit of fudge factor in that also, because the fellow who's doing the block work will be able to fudge on the footing a little bit to bring that block wall right over nice and square up to the back side of this post. I'm anxious to see the gate go in for a couple reasons. Not only will it reestablish security on the site, which, believe me, is important, But number two, I designed the darn thing. Nate and I were talking, I guess it was over a year ago now. I was in Oregon, he was down here, we were kind of brainstorming the design, and I sat down and on the back of a piece of printer paper, sketched out a design for a set of gates that I thought would sort of address his sort of aesthetic and be light enough to swing and operate and heavy enough to stand a little abuse and sort of a less is more approach to a gate. I scanned it, I emailed it to him, he gave it to his engineer, the engineer stamped it, attached it to a set of plans, and so I'm going to get to watch another fabrication shop build a set of gates that I designed.